Hello everyone, you are all welcome to lecture number 1303 and today's topic is lensless technology, that is without lens, and 3D imaging. This lensless technology with 3D imaging is called holography, and hologram is formed on photographic plate. Before this holography, actually two terms are used nowadays. One is called photography and other one is called holography. So photography means it is the recording of the reflected light wave in presence of lens, and which provides flat photo. Before it was black and white, now it is colored spectrum. So it is flat and it is not giving the concept of depth and dimension. Depth and dimension is missing in photography, and the whole world, when we are talking of world, it is dimensional, it is having depth. So it was not possible with this traditional photography to have dimension as well as depth. It was only giving the flat photo. But when the concept of holography came, then we got 3D dimension. Means we got the depth as well as dimension. And it has history. History is like that in 1947, one scientist was working in England, UK, on electron microscope. At the time, it was very latest discovery of electron microscope, and he was not getting very clear resolution of the object. So what his name was Dennis Gabor. So Dennis Gabor, he was awarded a Nobel Prize in the year 1971 for his holography work. It is he who coined the word holography. So he thought that since resolution is not very good, so he added one more electron lens to have high resolution, and by addition of second lens, that he called holography. So in the case of holography, what is happening, once that light is reflected by one lens, and again it is not forming the image, rather than it is stored in the form of, that is called hologram, is called hologram. And here you are getting photo, flat and 2D. Here it is hologram with depth and dimension, and no depth and dimension. And so he got that hologram, and we have one pair of eye. So when we are looking any object, both our eyes are not 100% identical, their reflection and all this. So they used such type of object whose two of the recorded wave can be blended in our mind, and that blending of the two images is called stereoscopic vision. They gave the term that is called stereo vision. So with this stereoscopic vision, and after the advancement, then it came into action, and this what hologram is produced on the photographic plate is coded. You cannot get any photo or image unless some light beam is focused, maybe laser beam or some other light. Only then you can see the holograph, and that is in depth and dimension. And nowadays, this holographic technology, it is very much in use globally for different purposes. For example, for security purpose, for data purpose, data storage. For example, now there is very smart 120 plate, and that is with the help of hologram, they are collecting data up to 3.9 trillion data, almost 4 trillion data in such a very small place. So in future, the data storage by holography is going to change, and there will be big revolution. Already it has started. Then in your currency note, all the coding is there. That is your hologram formation with the help of holography. Then it is widely used in dentistry, endoscopy, ophthalmology, for many places. In marketing, inside house, drawing room for beautification, creating lot of different type of holograms, and sending secret information in the form of hologram, where they can decode it. If you are going to buy, for example, in Dubai, if you want to see any multi-story building, maybe what is the position of particular flat at 80th or 90th floor, by sitting there on ground by hologram, all are there, hologram of every floor. You can see inside very good building. So that I am showing that hologram of Dubai. So this is the very simple camera with lens. Our eye also is just like camera, same principle. And here, with the help of lens, your reflected light from any object is recorded, and it is flat, and it is not having depth or dimension. The whole world was flat, but now it has got dimension and depth, while we are using holography in the form of hologram. So here it is seen that two lenses are there. One lens, after that light is striking to one mirror, and in presence of laser beam, hologram is created, and that hologram in presence of light is giving full clear picture of hologram which was coded. This is holographic image. It is not photographic, it is holographic image in the form of hologram, and once light beam is focused, it is giving the fluorescent image, that is called holography. It is hologram, and this hologram is coded, and it can be decoded in presence of good light like laser beam or any particular light where you can see very clear picture. This is real 3D holographic image of one big house with dimension, and it is 3D, and also you can see the depth, and it is in the form of coded hologram, and in presence of light, big very clear picture inside, outside, all dimensions are shown. This is the work of holography. So here I have given in a very simple way how the discovery of holography came by one British scientist while he was working on electronic microscope, and that second lens was used and that was created, that is hologram, and that hologram can be illuminated and all the information it will carry we can see in presence of light. So number one, photography is basically the recording of intensities of light wave reflected by object and image by lens. That is your photography. But here depth and dimension cannot be seen by our eye, and this is the reason, that is why photograph is flat and two dimension image, and A and D, and sorry, let me correct it, and two dimension image. Number two, strictly speaking, a normal photograph contains only one viewpoint. To see the depth by our eye, we need minimum two viewpoints. Each eye record different viewpoint. Then our brain blend these two view of the two eyes to view and to see the depth. Such kind of vision, where by brain it is blended, is called stereoscopic vision. Number three, the technology of holography was developed by a British scientist, physicist named Dennis Gabor in the year 1947 while working in a research lab in England, and holography invention won him Nobel Prize for Physics in the year 1971. Dennis Gabor was working to improve the resolution of electronic microscope, which was limited due to poor performance of electron lens. To solve this problem, he used two lenses, was called holography. So the word, once he used two lenses, he called this technique as holography. And image process known as wavefront reconstruction. This main thing is wavefront reconstruction, and that will create the hologram. And in Greek term, holo means whole or complete, and graphy means writing. This was recorded on photographic plate, and that was called hologram, which contains entire information about the object and which can be viewed later on by illumination of that photogram with light, and that hologram image, what it will show, it will be having three dimension with depth and dimension. So very soon we are expecting holographic television, and the future of holographic technology is having lot of potential, and there is no limitation. It is limitless. Number one, data storage is very, very important use nowadays. Holographic versatile disk, that is called HVH, a 120 disk that can store the data up to 3.9 terabyte, and it is expected that holographic data storage would become the next generation's most popular data storage. Number 2, security purpose. Very important use of coding of information in the form of hologram. Actually, hologram is coded and it has multiple purpose and use. Hologram called security hologram, and this security hologram is mainly used in currency notes with multi-layer different color. That's why others cannot copy. They can print, but holography multi-layer they cannot create. So that is used mostly in currency notes. Number 3, cryptography. Cryptography is holographic technology is used in secret communication to have secret information in the form of hologram, and they can decode it. Then medical applications used in endoscopy, dentistry, ophthalmology, urology and pathology. Holographic microscopy. There is lot of potential of holographic microscope in freezing the biological specimen, and that specimen hologram can be decoded, and that has lot of potential. Then other applications. There are a lot of other applications, like holograms have lot of applications. For example, a museum, aquarium, drawing rooms, new type of artists. Now there are new type of artists and they are called as holographers. Just like photographers, now we have holographers. And holographic optical elements, HOEs, used in heads of the aeroplane, cockpit, and in that way the pilot can read so many other things, and at the same time he can see the vision. That is the beauty of holography. And now very soon we are going to get holographic television. Is on the way, motion pictures, that 3D, and in future the holographic technology is going to be limitless. With this, I will stop. Thank you very much for watching the lecture.